Welcome to homework.
A type of problem like this is best solved with a type of chart like this, which tells you the chemical shift ranges for various functional groups. At that point, all you have left to do is identify what kind of functional groups you have and then where they would appear on this chart. So at first, we have cyclohexane, which just contains sp3 carbon hydrogen bonds, or alkane, fully saturated alkane carbon hydrogen bonds, which is right here in our chart, right? So that range is 0 to 1.5. That's where I would expect A. That's ppm scale. And let's look at B. B, we've got the hydrogen on a carbon neighboring a carbonyl. And that is shown, let's see, they're not in aldehyde. We're just looking for carbon neighbor ketones, which is exactly in this region here. So that's going to be about 2 to 2.5. So alpha hydrogens, I guess, would be the name for those types of hydrogens. All right, then we've got benzene ring. And we will find that aromatic hydrogens are further downshifted than your typical sp2 carbon hydrogen bonds. So they actually have their own little region in here called aromatics, typically appearing anywhere from about 6.5 to 8.5. Okay. And now we've got dichloromethane, or DCM. So consider that hydrogens bound to carbons that are bound to chlorine are around 3 to 4, but that with two chlorines acting in tandem, this will probably be on the higher end of that. So I would even go as far as say to 4 to 5 ppm. Right. This is just assuming one chlorine, but we've got two. And each electron withdrawing group you add, or electronegative group you add to that carbon, you're going to further deshield the hydrogen and push its signal further downfield. Okay. Finally, oh no, not finally. This is like second to last. E. This is like an aldehyde, and it's also neighboring another carbonyl, but for the most part, we can just look at where aldehydes appear, somewhere between 9 and 10. Although, once again, with that neighboring carbonyl, this may be on the higher end of that. So let's say about 10.5 would be fair. 9.5 to 10.5. And finally, we have hydrogens that are attached to carbons that are attached to nitrogens. So they're part of amines. And here we go, right about between 2 and 3 ppm. If you look up NMR functional group, chart, you can probably find something like this, which is good to study from or good to have nearby when you're doing NMR problems.